For the missile sim, I'd like you guys to imagine a sphere over here that has a bunch of points inside of it. So we're going to turn that sphere into a volume and scatter some points. At every frame, the location of these points is going to change. And we also have points down here along the surface that we'd like to collide with. And at every single frame, these points are also going to change. Now, all we need to do is match up the ID of one of these points with the ID of one of these points. That will then give us the ability to draw out a velocity vector, which then can be used in a particle simulation to send off a missile towards a particular area along the surface. That's the general idea for this missile sim, and then once we have the points collide with the surface, that will trigger all of the various pyro effects. In Houdini, let's create a new GeoNet. We'll call this our missile sim build and color that purple because I like making all of my build networks purple. It's kind of a fun color. Let's do an object merge. And we're going to the combined islands. So that should be combined geo islands, and we have our colliz polys out. Just to make sure, combine geo islands and colliz polys out. We also need a sphere, so let's create that. Go up here and hop out of the camera, maybe go somewhere over here. And yes, that is outside of the camera's view. Let's go a little bit further out though. Turn this up a little bit and maybe even scale the sphere a bit differently as well. Kind of go in a general area like this. I'm going to turn this into a polygon, add a few more polygons via the frequency, VDB from polygons, and now use a fog VDB, where we can then use a scatter, and we have points. With this scatter, I don't want any relaxed iterations on because that takes extra time and it's not necessary. For the global seed, $F, and for right now, 1,000 points is just fine. If we press play, we end up having this. And before we get too much further in this project, be sure that we go to our global animation options and that our frames per second is at 30 frames per second. You can do whatever FPS you'd like, but just in general, it's good to check on this before you set any keyframes. Okay, so we have that. Now what about points along the surface? We can use an attrib paint, and if we hover over here, Control Shift right mouse, drag. Let's go to our attributes, and we'll call this the terrain scatter mask. I'm going to copy that onto my clipboard because I'll use that here in a minute. And I'm just going to paint the likelihood that a missile will hit any area along here. So this attribute here will be part of the scatter density. And if a point happens to land in any one of these areas, that will trigger the pyro effect. Looking from our camera, I think that seems like a nice area for candidate explosions, especially in this area. Let's be sure that that area is really red. And now that we have this, we'll also do a scatter, this time using that attribute we just made for the density. So paste that in. And just like before, turn off relax iterations. And $F for the global seed. Okay, so now what we need to do is draw a velocity vector between the points of the sphere and the points along the terrain. So let's see if we can, there we go, see both of these guys. In order for this to happen, we're going to use a point wrangle, and in that point wrangle, we need to, first of all, identify which point we're trying to read the position of, and then use the difference in the position to create the velocity. So first off, what sort of ID can we use to match up the two collection of points? Fortunately for us, we have the same number of points over here. We have 1,000 points on the terrain as well as the sphere. And that means we can rely on the point number to match everything up. So these IDs over here, this starts from 0 and goes all the way up to 1,000. Likewise over here on this scatter, because it's two separate branches in our network. So just to make sure that that always stays intact, let's actually copy the parameter on the sphere for the scatter and paste it over here to the scatter on the terrain. Just again to make sure that these 2 point counts always match up. Also, let's take our sphere and turn that over here to the left because that's where we're going to be emitting from. And then we'll just take information from our terrain like so in the second input. Okay, so now we can take our velocity vector and set that equal to our current position minus what is going to be the collected position. And what's the collected position? Well, we need to use a point expression to gather the position of the corresponding points. So if we take a point expression, say, all right, go through input number 1, that again is the second input because this is an index of 1, and we take a look for the position, we can then match this up with point number to gather the position. So that is going to be a vector called collected pos equal to that. And if we do that, let's go ahead and turn on our trails. And it looks like we have a velocity going towards that position. However, that velocity is inverted. So let's see if we can do this the other way around. Let's take the collected position minus our current position. There we go. Now all of these points have found a corresponding ID somewhere down there, and they are pointing towards those locations. Awesome. So now let's use a pop network to send these points flying off. In the pop nets, we can just say points. And if we go to birth, let's just leave this alone here for a second. Be sure that everything's working. If we go through these frames, now as you can see, we are just bombarding the terrain with tons of different points, like so. That's obviously a little bit too intense. So we need to actually only emit every once in a while. Let's say that we emit 1 particle per second. Let's actually create a static object here so that we can have something that our particles collide with. For that static object, we're going to use an object merge. And we can actually just take a copy of this guy up here for that. Set that to the second input. And well, actually with a static object, we'll just make a null here. And we'll call this our colliz polys sim. And then on the static object, we will find colliz polys sim like so. The double periods / says go to the current DOP network, go up 1 level, and then find colliz polys sim. Create a merge DOP right there, plug that all in. Be sure that the effector relationship is mutual, or that if it's left inputs affects right inputs, that this static object is in fact the left input. And now, before we simulate anything more, turn off the display geometry, go to collisions, turn on the collision guide, because this is what our DOPNet actually sees. For the uniform divs, I'm going to change that to about 150. And now we have a decent resolution for this geometry. So now if we go ahead and play forward, we have our particles hitting the ground. Okay, we don't want them bouncing off though. So let's go ahead and change that collision behavior. If we go to our pop solver, collision behavior, we can add hit attributes. That will allow us to, let's say, take this and have it stop once it hits. So Now we have our particles going forward, and as soon as they hit the ground, they stop. It's a little bit difficult to see this, so I'm going to our display options by hovering over the viewport, press D, Geometry tab, and turn up the point size so that it's really obvious where those guys are. All right, there we go. Now, once we collide, we want to say move to hit because that will bring our particles back to the surface in a proper area. Notice how this guy is kind of along the surface. This guy's hovering above. They're a little bit strange, but they're not really along the surface. If we say move to hit, that will fix that. So now they are properly interacting with the surface of the mesh. Now, just thinking ahead of time here, we'll be using the pyro burst source right here. And that pyro burst source is pretty cool, but it requires a start frame attribute called start frame. And in order to get this attribute on the points as they hit, we need some sort of way to figure out the moment in which they hit the surface. So just again, thinking ahead of what we're trying to do here, we need to go to our pop solver and use this color hits. We do have another thing called the collide group up here, but I found that particular parameter is very temperamental. It only works about half the time, in my opinion, especially when you have things that are really moving quickly, like in this situation. And so for that reason, I would recommend using the color hits whenever you can, because this collide group doesn't really do so well. I've, by the way, looked at how to fix that issue with the collide group. People say you can turn up the P scale so that it detects collisions better with the high velocity, but honestly, it's better to just use the color hits. It's much more predictable. And I'll show you how we can take this group through a SOP solver, or these colors through a SOP solver, that is, and figure out the start frame from there later on. But anyway, just thinking ahead, we want this color hits, and we want to say move to hits for this to work. In the next video, let's establish a good constant birth rate. We'll figure out that start frame and get everything up and running with the pyro burst source.